I am Taylor Walton. I am the ASGSR Student Board Social Media and Web Coordinator. It's my pleasure to welcome Dr. Anjali Gupta, Dr. Erika Wagner, and Dr. Joya Masa. To start, let's start off with Anjali. She will be our first speaker. And Anjali is a part of the business development team at Axiom Space. She is leading the life science efforts for her team. She began her career actually with Roche and Pfizer doing early stage drug discovery. Our next, following Dr. Anjali, we will be hearing from Dr. Joya Masa. She is a scientist at the Kennedy Space Center, working on spacecraft production for the International Space Station. She has a PhD in plant biology from Penn State and has worked in the areas of plant space biology and bioregenerative life support. And our last speaker, but certainly not least, is Dr. Erika Wagner. She's a Payload Sales Director at Blue Origin, a private space company. She has previously worked with the XPRIZE Foundation. She has a background in Biomedical and Aerospace Engineering. All right, well, let's start off with hearing from Dr. Anjali Gupta. Thank you.
Great, thank you for the introduction, Taylor, I appreciate it. And thank you for everyone who's joined us on this Saturday morning. Looks like we have a really great crowd. So I'm going to begin with a little bit about myself, building on what Taylor has just shared with you. So the goal here today is to discuss, your guide to a career in space, a hitchhiker's guide, a play on the famous book. So I'm going to tell you a little bit about myself and then talk about how you might be able to go from where you are today to where you want to be a career in space. So I started out with a bachelor's in neurobiology from UC Berkeley many years ago. That led me to start a PhD in physiology at UC Davis. And then I took a little detour, and instead of finishing up my PhD, I went on and started a career in pharmaceutical as an electrophysiologist. I was in early stage drug discovery where I did, I was an electrophysiologist and worked with just a really super cool group of people to develop drugs for pain. I went from Roche to Vertex Pharmaceuticals. That's where life took me, from the Bay Area down to San Diego. And then I was recruited over to Pfizer to do safety pharmacology. So in all of these years, I learned my art. I set up a very strong foundation in drug discovery, studied and practiced preclinical drug discovery. And then I pivoted into marketing. That led me into clinical trials for digital health. And from there, I had attended a conference, and I wanted to, actually it was 7 years ago today, where I attended Arthur C. Clarke Center for Imagination Spaceship Century conference. And that's when I realized that I could actually translate my passion for space into something practical. I was in line behind Jill Tarter, and she had just finished a talk, and I asked her, how do I break into this? She said, be persistent, apply for NASA fellowships, NASA grants, and attend a lot of conferences. So that's exactly what I did. So you can see my backward step here. So as you can see, this is not a linear journey. So I took a backward step. I went back to school. I finished up a PhD, applied for a NASA fellowship, postdoc, translated. So I was, then in that time, I was recruited to Axiom. And so that's where the journey is. And in that time, I attended a lot of conferences. I presented at a lot of conferences. And both of the women, the panelists, amazing esteemed panelists, are very much part of that journey to where I ended up. So that was me. And I was probably not representative of the group that is here in the 70 plus audience that we have here. I've been told that plus 50%, close to 60% are students who are undergraduate or graduate schools. So let me focus on you. So here's my list. Here's my list for what you might be able to do. I'm just going to go through this. This is the framework I've used is the 6 WH questions. So who are you? Start with who you are. Define yourself. Create a personal vision statement and a personal mission statement. I created a vision board, and I had that vision board up in my office, my home office, and then now it's in the garage. But it really helped me understand where I wanted to go from 7 years ago to where I am today. Define your brand. Like, who are you? You think about major brands, Apple, Microsoft, Coca-Cola, whoever your brand is. Create your own brand. Understand your own personality type. What are your strengths? What are your learning styles? How do you work with people? Figure out what you love doing. That's very important. It's not just about having a career in space, but figure out, what do you love doing? Do you love making spreadsheets? Do you love managing projects? Or are you an artist? Or do you love being out in the field? And then, what puts you in a state of flow? Where do you get lost doing something? Is it doing an experiment on the bench? Or is it reading a very complex document and figuring out all the edits that you might need to do for that document? And then what kinds of tasks do you absolutely dislike doing? I mean, for me, it was, anything repetitive. After I mastered something, I just couldn't keep doing the same thing over and over again. So figure out who you are. Then ask yourself why. Why do you want to have a career in space? That's a really important question, because if you understand why you want to be in space, then you'll be able to articulate that to your interviewer or to your colleagues, and that passion will come through. And then what is your knowledge base? What do you know? So what is that strong foundation that you bring to a career, to a job in space? Is it your scientific skills? Is it your people management or project management? So list out your skills and list out your abilities. These are, what's somewhat innate to you. Skills are something that are learned and that you develop. And then I mentioned earlier, what is your working style? Are you an independent contributor, or are you a team or group work type of a person? And then finally, what is your timeline? So if you're starting out in high school, you may have a very different timeline than somebody who's in undergraduate or graduate school. I like to use a spreadsheet, Excel spreadsheet, lay out those timelines over 4 years or 8 years, and then put in mile markers. Okay, at 2 years into college, I want to do an internship at XYZ. I want to do a second internship in a summer, and so on. To create that 4 to 5 year calendar, depending on where you are in life, and then put in those mile markers. Where do you have a geographic preference? Do you have a sector preference? Do you want to be in academia, be a professor? And, you're going to hear from Dr. Masa, teach plant biology. Do you want to work for the government, or do you want to work in industry? Think about all of those questions. And then, do you have an idea of a particular place where you can imagine yourself working? That's also a good place to start. And then I have a long list of hows. So LinkedIn is a great platform. It's a great platform for professional development, for amplifying your own brand and your own signal, and connecting with other like-minded individuals. Couple of gripes that I have: personalize your invites and show respect. If you're reaching out to somebody, indicate, hey, Mr. So-and-so or Ms. So-and-so or doctor, and explain why you're reaching out to them. And I prefer, or try not to ask for something, just link in and follow them. And then maybe down the road, as you develop a relationship, you can make that ask. Volunteer, lots of opportunities through ASGSR and other places. Portfolio, create a portfolio of your work. What are your work products? That's really important, especially for somebody starting out. What is it that you can provide or offer to somebody, to a new employer, or to an internship, or to a volunteer agency? Document your wins. It's really important to have a folder in your email box and call it wins. Put in stuff, whether it's a congratulatory email or something that you did really well on. Just document that. And reflect on your failures and document lessons learned. That's really important, and that will come in handy while you're interviewing. Own your mistakes, and then separately have integrity. If you make a mistake, own up to it. Don't hide from that. Be a self-starter, take initiative, go above and beyond. Always put out your best work, because I promise you it will be noted. Read, and especially read perpendicular to your art. So if you are an engineer, read something that's not engineering. If you're a biologist, read something that's not biology. So it's always important to read perpendicular to your art. Learn to write. I can't tell you how many times I've come across emails or documents that are not properly formatted or written, even with proper grammar. Learn to write your own letter of rec. and map that letter to the purpose that it needs to serve. That's a really good starting point. If you can write your own letter of rec, then you can probably explain to someone else what's your value. Have a resume ready, create an awesome, unique resume that represents you. It's your book cover, and make it relevant. Prepare for your interview. Everything above that I've stated, that's part of that interview process or the preparation process. And then when you look at the job description, deconstruct it and map it to your own resume. Read job descriptions. That's something that's a fun and interesting thing to do. It tells you what's out there, and then it also tells you what you might be capable of. And finally, try to create your own ideal job description. So that's another way to map your career from where you are to a career in space. Journal, even if it's just a few lines a day, and there are journals like that where you can document 2 or 3 lines. This will help realize your progress. There are not enough internships around to create your own opportunities. Manage your brand. It's an active, ongoing, continuous process. One important thing is play for the team and win for the team. It's not about you, it's for the entire team. Say thank you to those who have helped you along the way, along your hitchhiking journey, and do it in a genuine way. Drop an occasional note to let them know what you're up to. Mentors, advisors, people who've helped you, they want to know what you're up to. Actively design your life. This is the most important thing. Be your own life's architect and edit often. Life is not perfect. It's never done. You're going to keep changing. You're going to keep editing your life. Take the long view. The path to your desired destination is not linear, as you can see from my own experience. Do your part and be ready when opportunity knocks. I love this quote from Louis Pasteur. Chance favors the prepared mind. So have your resume ready, have your letter of rec ready, be ready for that chance. Finally, also very important, practice gratitude every single day and pay it forward. So don't panic wherever you are in your journey. It's a continuous evolving process. And just to play on this book, these are my 42 pieces of advice. Just really quick, I know I'm almost out of time. I want to give you some examples of careers. So we have somebody who is a seamstress on our team, on the Axiom team. She's actually working on sewing and selecting materials and whatnot for our on-orbit human habitat, where for these crew quarters. We have another person who's an amazing illustrator. He's taken a design of the Axiom station and sketched it out just to add some spice and flavor to our presentations. We have somebody else who's a graphic designer and also an architect. And he's taken this and created just some amazing images. Finally, if you're a scientist, here are some opportunities. As a scientist, you can, spend 3 months studying for the patent law exam and become a patent lawyer. We will need patent lawyers in this space. And then there are lots of other science writer, marketing manager, all of that. Finally, I want to point this out. There is a scholarship that Axiom is sponsoring. I encourage every student in this meeting to consider applying for the scholarship. You can find out more at axiomspace.com/stars, and the applications are due June 30th. And then finally, thanks for your time, and I'm happy to take any questions at the end.
Thank you very much, Anjali. Wonderful presentation. All right, next up is Joya Masa, and I see we have a lot of new people here joining us. Just so everyone is aware, we are recording this meeting. And at the end, we will have a short Q&A, so please put all your questions into the chat. Thank you. Joya?
Thanks, Taylor. And that was a wonderful introduction, Anjali, and it really set the stage. I'm going to get a little more into what I do. So I work in the area of space crop production, and I'm a life sciences project scientist at Kennedy Space Center. So for that job, I actually wear 3 different hats. I lead or participate in research in the area of space crop production. I also help external investigators to get their plant research to work, whether it's on space station or on, in our hardware and NASA supported hardware. And then the last part of my job, which is probably my favorite part, is I get to do a lot of education and outreach activities with students and teachers and the general public. Just sort of my story pictorially, I was actually born in Florida, and I grew up about an hour and a half from Kennedy Space Center, so in Central Florida. And that was a really influential time in my life, because it was when I took my first agriculture class when I was 12 years old in 7th grade. My agriculture teacher at the time was selected to come to Kennedy Space Center for a teacher training program they had. And it was about the plants and space work that was going on in life support systems. And he brought back 40 hours of video, and I was just captivated by that. I knew I liked horses. That was why I took an agriculture class, but I didn't really ever think about, this aspect of science until I learned about it from this outstanding teacher. And so I had the opportunity to work with him, to work with my high school agriculture teachers, build hydroponic systems, and actually start doing some research in high school. They liked the fact that I was interested, and they helped to encourage me in that. I went to Cornell University for undergraduate, and I continued with, my interest in plants and crop production. I did some side experiments in the lab that I worked with, and I learned about growing plants in controlled environments in this program. And I also had an opportunity to study abroad in Australia, which was a really great way to give me a perspective on who I was and where I lived from outside. And it made me realize that we're really all the same, and that national barriers just don't really mean a lot in the grand scheme of things. Also, as an undergraduate, I had an opportunity to be a NASA intern at Kennedy Space Center, and that was a tremendous influence in my life. It was sort of a plus up, a bonus to keep me on the trajectory of what I wanted to do. And I got to come here and meet a lot of the amazing people that were working in this area. I went to Penn State as a graduate student, and I was more in a cell biology program. I worked with Dr. Simon Gilroy, and I studied plant root responses to touch and gravity. And this was a lot more fundamental biology than the applied agriculture side of things. And while I learned a lot, and I had some amazing, experiences as well in graduate school, I realized that wasn't really my happy place. I wasn't as happy looking at cells in a microscope or doing the more fundamental parts of things. I did have an opportunity to be involved with a student spaceflight experiment where we looked at some germination and built hardware, and that was pretty exciting, even though the experiment didn't work, which isn't too uncommon. While at Penn State, I started going to the ASGSR meetings. And as Anjali said, going to these, national and international conferences and meeting researchers is tremendously influential for your future career, because you get exposed to all of the different things that are being done. And while at ASGSR, I met Dr. Carrie Mitchell at Purdue University, who later invited me to interview for a postdoctoral position in his lab. And at the time, I was kind of burnt out after grad school, as many of us are, but he opened up the opportunity of doing more applied work in agriculture as part of a NASA center that he ran. And I loved it. It was back to my comfortable zone. I was working with large crop plants in greenhouses and growth chambers and studying LED lighting, and I really enjoyed it. An opportunity to do a postdoc at Kennedy Space Center opened up a few years later. I'd already been on the job market for a while, but it was right during the recession, and there weren't very many jobs. And I still really wanted to be at Kennedy Space Center. So I didn't want to be a postdoc anymore, but I really wanted to be here. And I kind of, did a bit of a Hail Mary and came down here, and I was able to be a postdoc with one of my now colleagues, Ray Wheeler, who is an amazing mentor. And I was able to eventually get hired on by NASA. So it was a a long journey, but it was kind of direct in some ways, and I'm really very fortunate to be where I'm at, and I know that. And these are the amazing people that I get to work with every day. This is, it's all about teamwork, and I think the different aspects of the team are what can make us successful. If you have only people like you in the team who only work in the area that you work, you're never going to solve the difficult challenges that we're dealing with for space. And so we have, scientists, we have engineers, we have many different flavors of both. We have project managers and payload integrators and interns and postdocs. And, the team is what makes the job wonderful, or not, depending on the job that you get. And in my case, I'm really, really blessed with the team that I work with. And so I think, it's really, undergraduate, grad school, especially, and then beyond that, it's really about the people that you work with, more than even what you do sometimes, because if you have a shared passion, it can make any job wonderful. And if you lack that, it can make it really disappointing. So, I'm interested in growing plants in space, and, why. I love this photo of Mike Hopkins showing a meal on the International Space Station. And you can see that each food item is individually wrapped and freeze dried. They have a pretty good menu, but over time, if you were to store this food, the nutritional quality and the flavor and quality texture degrade. And so we're looking at growing plants to supplement this packaged diet in the near term. Plants can also provide psychological benefits, and we're actually starting to capture data on this now. And that's a really interesting area that, might be kind of different for most scientists to think about. And then, of course, there's the plants, helping to recycle the atmosphere, recycle the water. And so that ties you in with the environmental control and life support systems community. So you can start to see how it becomes very interdisciplinary very quickly. When we're thinking about how we might grow plants in the future, we're probably going to grow them, something like this, maybe densely packed layers of plants under electric lights inside the habitat, protected from the hazards of space radiation and micrometeorites, maybe underground, maybe in a structure like this with just really thick walls. In a near term, we might be like in this chamber, an entire module that could launch on a rocket and they could hook to other modules to build a habitat. And we're growing plants like this, on Earth today. There's indoor agriculture, vertical farming, and we align very closely with that community as well. We learn a lot from them, and we share a lot of information with them. Our goals for space crop production are to ensure food system security on long duration mission beyond low Earth orbit. And food security is really the condition in which the crew have continuous access to safe and nutritious food, which meets their dietary needs and their food preferences. It's got to taste good, right? In order to maintain peak health and performance. And so first we're looking at supplementing that prepackaged food with nutrients. And later we're starting to look at replacing calories to facilitate Earth independence. So right now we're kind of on the left-hand side of this chart. We're looking at salad crops and herbs to augment the packaged diet. And ultimately we want to get to the staple crops, but we'll need some way to cook them. For, potato or sweet potato, those are pretty easy if you can cook them. Things like wheat and soybean, you need more equipment. That's launch mass, but that's also labor. So then you need automation and robotics. So you can see all these different skill sets start to converge. The more we try to build an ecosystem that will survive without Earth. And we think of these challenges, you can look at these challenges and think of the skill sets associated with them. So for deep space, we have microgravity. We have really strange fluid behavior. So we work with fluid physicists to try to understand how to water our plants. For surfaces, there's dust. Dust is a hazard. We have partial gravity. We don't even really understand what that's going to do. Shared between both of these, we have hazards like radiation, reduced pressure, micrometeorite impacts. At the bottom here, we have some crop-specific challenges that are just the same as for any agricultural system. How do you grow productive crops with stress tolerance, optimizing your environment, scheduling, all that systems integration so you can know when things happen, when they need to happen. And then all of these share challenges of, growing small productive plants, food safety and microbiomes. Our microbiologists and molecular biologists are an absolutely critical part of our team. The nutrient output, that goes to our chemists who are critical to our team. How to be sustainable, how to recycle our inedible wastes and grow crops for long durations. That gets really into environmental engineering and composting and all of these different aspects that pull from a lot of fields. We have biological stresses and non-biological stresses, limited vehicle resources, etc. Right now, we're doing a lot of testing on the International Space Station, which is an amazing orbiting laboratory for testing these future technologies that we're going to need to go onto the moon and Mars. And we can do it, safely without the crew being too far away from home or being dependent on them. And two of the things that we're testing are our large plant growth facilities, veggie at the top, which is a really simple kind of astronaut garden. It really is only a low power system. It has lights and fans, and everything else is done by the astronauts or is manually controlled. And then the advanced plant habitat at the bottom, which is really our plant physiology research chamber, has over 180 sensors and control systems. And so we're learning a lot from both of these that are helping us to decide what a future crop production system will do. And here's just a quick video showing veggie. This was one of the first veggie missions that I was the science lead on. And here you see astronaut Kjell Lindgren harvesting some lettuce that was grown. This was the second mission of veggie, but the first time the crew actually got to eat the crops. And so being involved in this, it required coordination with the flight surgeons, with the safety folks, trying to understand all of the human factors associated with growing and eating crops, which was really a new field for me, and really an exciting thing to get into. I mean, I'm a plant physiologist by training. I don't know about these sorts of things, but I learned. And I learned to be able to talk to different people in a wide variety of fields to help accomplish this. And here you see, Scott Kelly, Kjell, and Kimia Yua, toasting their lettuce like we all do at home. Seeing them eat that, was just a wonderful accomplishment for all of our team. Since then, I've been able to lead a team in the VEGO4 experiments. This was a competed grant where we were studying light quality, so the impact of how color impacts the growth, the nutritional composition, the flavor. We're doing taste tests with the astronauts, and the food safety of this Mizuna mustard. And we're also doing these assessments of crew behavioral health, the psychological impact of plants. So getting into another field. And this is a collaboration where I'm leading a team between Kennedy Space Center, Johnson Space Center, Purdue University, and the company Orbitech. So it's a very diverse group that we get to put together to get things like this to happen, to have people eat produce, enjoy it, and to learn and get science out of that. So I'll just stop there and thank you all, and just end with a beautiful shot of something else that we don't always think about associated with space, but that's art. This was a flower arrangement that Scott Kelly did, and growing crops helped to enable this art in space. But, as Anjali said, there are roles for everyone. You just have to find your passion and then run with it. So thank you.
Thank you, Joya. Wonderful presentation. All right. Our last speaker is coming up, Dr. Erica Wagner, and then right afterwards, we're going to have a short Q&A. So put your questions in the chat. Thank you, Erica.
Thanks, Taylor. Now, I love the fact that you're seeing this same career pocket through so many different lenses. In so many ways, the three of us are very similar in the journeys we've taken, and yet it's so diverse. So I hope you're getting something out of these different perspectives. For me, this is where it starts, right? That since I was really, really young, I mean, so young, I don't even remember where it started specifically. I have wanted to go to space, and I wanted to send people to space. And I think when I imagine these moments. These are the whys that drive me every day. You know, I sort of think about the history of where this has gone, and all of humankind, we've only sent fewer than 600 people to space. And it's sort of crept up by ones and twos and then, fours and sixes. But I'm really curious if that was what the first 50 years of spaceflight brought. What comes next and how do we change that? My first book I ever owned about space is this one. I still have a copy on my bookshelf. I think that the ways in which we get inspired really drive the futures we envision. In this book, there was a picture of Valentina Tereshkova, and the first woman that was ever, up in space. And I remember seeing that picture and thinking, oh, that could be me. So that's been an important lesson to me, that this sort of you are inspired by the things you see around you. And it drives me to do a lot more conversations like this and outreach in my own career to try to open up those doors and visions for others. I went through my childhood knowing I love space, knowing I love science, knowing I love problem solving. Ended up doing my undergraduate in biomedical engineering at Vanderbilt University in Tennessee. And then by the time I got to grad school, I was in the human systems lab at MIT in a program in bioastronautics. And I was using centrifuges for my master's work to study vestibular physiology. In my doctoral work, I worked with a team of students to design a spacecraft for doing biomedical research in space, and wrote a thesis on musculoskeletal adaptation to partial weight bearing. And what I found in the course of doing all these things is that I'm an okay engineer. I have a PhD in engineering. But what I loved was working at the intersection of the fields, at the big picture, at the strategy. And so I started looking for opportunities that would lead me away from the lab, away from a career in academia, but towards something that was a bit broader view of the world. So that centrifuge that I used for my master's thesis was designed by a gentleman named Peter Diamandis. That is his graduate work. Peter went on to become the founder of the International Space University, the CEO and starter of the XPRIZE Foundation, and a number of other things. And I took mentorship from Peter in my lab and found myself standing on the flight line in Mojave, California during the XPRIZE launches of Spaceship One. And I remember standing there at dawn as this vehicle was going down the taxiway and looking around me. And I was surrounded by the who's who of our space world. I had the Aldrin family on one side of me. I had the head of the FAA on the other side, Scott Crossfield, who had piloted the X-15, Wally Funk, who was one of the Mercury 13 women. And I'm watching these folks who have seen everything over the last set of decades. And they look like kids in a candy store. And it helped me to realize that this thing that I found exciting was really going to be transformative, that this opening the space adventure to more people and more uses was something that was going to drive our entire field over the next few decades. So there's a quote I love from Louis Pasteur that says, "Chance favors the prepared mind." And I had an opportunity. I got a call from Dr. Diamandis, and he said, you know a lot about extreme physiology. The things that you know in space apply in other environments. You also know about how the innovation process works and how we make things real. I'd spent a lot of time with our biosatellite program, sort of in an entrepreneurial mode. Right? Even though I was in a university setting, I was really being an entrepreneur and learning those skills. So he invited me to come join the team at the XPRIZE. And over the next few years, I managed their university collaborations and also their investments in space, deep sea, and high tech. One of the things I was proudest of there was our work in ocean health, looking at ocean acidification and acidification monitoring. But I also had a chance to work in all sorts of really cutting edge arenas and with a set of advisors that were really inspiring to me in terms of their breadth of thinking. So we worked in deep sea submersibles, global health and tuberculosis diagnostics, self-driving cars, electric aviation, brain-computer interfaces, vertical farming, and advanced food technologies. And I got through about 5 years of work with the foundation when I started to say, I love what I'm doing. I love being at this cutting edge, but I miss being part of a bigger team that's doing the doing. Right? We were asking great questions, but other folks were doing the innovation. So I started looking for opportunities that would lead me back into the space world and back to working with a space team. And because I love quotes, here's one from Gandhi, who said, "The best way to find yourself is to lose yourself in the service of others." And I've certainly found throughout my career that that's been true, that I have gotten the most out of the things where I have been giving back the most. And one of the ways that sort of took a very career-oriented turn for me was sitting on Facebook one day. This is early days of Facebook back in 2008. And one of my mentors posted that he was going to create a new market for suborbital spaceflight. I was very excited about it. So I sent him a note and said, what is it? How can I help? I'd love to be involved. And he said, yeah, you should call me. And I ended up in service to the Commercial Space Flight Federation on their suborbital applications researchers group, and bringing to bear my understanding of the space life sciences to think about what these new commercial vehicles could do for us in terms of research and technology maturation. And through the twists and turns that underlie any career move, I landed at Blue Origin. At the time, our team was 170 people. I was one of 2 that was externally facing. And I was really coming to bring to bear that understanding of science and technology to help customers make research possible. And we've had a lot of fun over the last 9 years. I've gotten to work with NASA teams that were working on combustion, small businesses that were looking at the next generation of plant growth technologies, research institutes that were interested in harvesting regolith on asteroids, fluid physics from university teams, and just sort of basic fundamental modeling and understanding of fluid movement and how it would apply to things like refueling spacecraft. And as Joya mentioned, arts and education are a huge cornerstone of the things that I find really exciting about the future of space and how we welcome new folks into our communities. This project that we did with the band OK Go to get middle school and high school students designing experiments that would develop art you could only make in space was really fun. Like Axiom, Blue Origin has been involved with the ASGSR for a number of years, and we love and are passionate about making sure there's opportunities for students. For those who don't know, we have a competition going on right now. Applications are due June 3rd, and what we do with this competition every year is select a student experiment to fly on New Shepard and to really advance the state of readiness of this community in doing great work in gravitational research. So when I think about where I am in my career, it's really that I live a career at intersections. I could have been a scientist, I could have been a laboratory engineer, but where I found that my superpowers are, insofar as I have any, is to be able to reach across all of these communities and to bring them together at the same table. I often say that my career is one of translation. I translate science speak for engineers. I translate engineering designs for policymakers, and I translate both of these for business decision makers. And so that intersection has really been a very exciting place for me. But there's a balancing act here as well. That these are my professional side of my life. I also have 2 kids and an awesome husband and a gorgeous dog. That's a balance that I have to find every day. There's a concept that I love as an engineer that says that balance is not a statics problem, it's a dynamics problem. And I find that really interesting, that we don't balance things by standing still, but we are in balance while we are moving and walking and working and playing. So I like to think of that balance isn't something that you have, it's something that you're creating in every moment. Back to the why, right? It took us about 50 years to get the first 500 people in space. The next 500 are not going to take nearly so long. I'm excited to see what happens when we open those doors wider to new users, new use cases, new dreams and new visions. And so that's why I'm here and why I do what I do every day. So let me stop the share and we'll move back to Q&A.
Great. Thank you, Erica. You actually had a couple more minutes if you wanted to finish up, but wonderful presentation. We have plenty of questions, so I have no doubt that we will fill this time. So I saw quite a few questions in the chat about international students and opportunities available to them. Do any of you have any experience you guys want to share with that?
Well, I can just start, from the NASA perspective, it's a real challenge, as I think probably the international students are all aware. Unfortunately, our internships are generally only open to US citizens or green card holders. And you also have to be going to a US accredited university. So there are definitely limits there. And civil servant positions similarly. Our contractor positions can be open to non-US citizens. And one especially important exception is the NASA postdoctoral program, where you don't have to be a US citizen to apply, as long as you're not from one of, a list of designated countries that unfortunately are not allowed. But, so we've had postdocs from India, we have a postdoc currently from France, we've had postdocs from Canada. So there's certainly opportunities to come on a research visa as a NASA postdoc.
I'll say on the industry side of things, the key word is ITAR. Right? This is the International Trafficking in Arms Regulations, and it's the State Department rules that govern how international participation can work in the space domain. Fortunately, research is not ITAR controlled. Right? You can be a researcher in any country, and or at least the vast majority of them in the world, and still fly things on private vehicles on the International Space Station. So the research domain is in many ways more open than the sort of launch vehicle domain. Interestingly, a few years ago, the U.S. State Department moved satellite technologies into the Commerce Department. This is all inside baseball. But what it meant is that certain industrial positions actually got more open. Things like space tourism is more open. Things like satellite development is more open than developing a rocket or a rocket engine. So things to be aware of, but definitely no lack of opportunities.
Yeah, and I just want to add that our scholarship is actually open and it's global to anyone who wants to apply. So that's another research opportunity, a proposal opportunity that is open to international students as well as US students.
Thank you all. We had a question earlier from Roxana for Angeli. She was asking about your approach to the cruise food. She was wondering how she and how others could get involved with commercial cruise space food, and if you have any input towards that.
Great question. Yes, as I believe we're working with quite a few various partners to develop the food. I don't have any specific information, but if you send me an email at innovate@axiomspace.com, I will follow up.
All right, thank you, Angela. Could you drop your email in the chat there so everyone can see it?
Sure.
Thank you. Right. The next question I will present. You guys answered quite a few of them. Sorry, my dog is eating food. The next question, Kushbo Patel asked earlier, Dr. Masa, about growing flowers in space. Could you talk a little bit about that? He's asking more about growing flowers for like mood and physical, psychological development and engagement for astronauts in long-term space flight.
Yeah, I mean, it's a great question. And obviously, as a plant person, I love flowers, and I try to make it a point to stop and smell the flowers a lot because, literally, because I think that's important for my well-being. And we did, we've only grown kind of one set of flowers specifically as ornamentals in veggie, which were the zinnias that you saw the bouquet of. I did a bunch of assessment before that. We wanted to find flowers that would kind of retain their petals and not generate a lot of debris, not generate a lot of pollen, low odor or pleasing odor. So there's all these things to think about when you're growing in a closed spacecraft. But I wanted something that the crew wouldn't feel kind of obligated to eat. And of course, you need flowers before you're going to make fruits or produce seeds, which, for long term is going to be really important. We always ask the crew when they come back, we have kind of a debrief with them. And we always ask, would you prefer more edible crops or ornamental crops in the future, or a combination? And they always say edible, which is really surprising because we've had some collaborations with the Russians, and from the feedback that they've gotten from their Russian crew members, the Russians want more ornamentals. So I think there's definitely some cultural differences there. Maybe the Russian food is richer, and so they don't feel the need to augment it, or maybe they value that more. when we did grow the flowers, everybody loved them. And so it was surprising to me that the astronauts don't really seem to have interest in growing more flowers, because when we've had other plants bloom, like recently we had an edible crop, the extra dwarf pak choi, which was a crop selected by middle school and high school students, actually, that had started blooming. And Mike Hopkins, who was taking care of that, took pictures of the flowers. All his crew members took pictures with the flowers, even though these are little tiny yellow flowers, not the most exciting thing. So I think they're focused on mission and they're thinking about food, but when flowers are there, I think they really enjoy them. And so, maybe some of this goes back to the whole right stuff mentality, like, let's just be focused on what's essential. But I think flowers are going to have a role in the future. So we'll see.
Thank you. Another question we had was from Pranav Patel about how to give yourself a competitive edge in trying to break into this industry. What would be kind of a great way for students, recent graduates, undergrads, high schoolers to kind of give themselves that edge?
I'll take a shot at that one, if I may. I think about that in sort of 4 different buckets, and I find it useful to tease them apart a little bit. One is the credentials you have. And what is the degree or the certificates, and that will often open a door, right? People see that and they filter on it. The second is the knowledge you have. What do you understand, and how can you bring that to bear? As does a company or a lab need to have specific? You're really well read in this area, or you have a lot of deep coursework in that area. A third area is your skills. And I think it's really interesting when people sort of try to figure out whether they should go to grad school or go take a job. You develop different skills in those different arenas, right? You may learn a lot about data analysis, big data analysis, or you might learn how to communicate really well. And you might learn a specific software package. So skills are somewhat separate from knowledge. And the fourth area is really network and who you know and how you're connected into the community. And that can come in a lot of different ways as well. Certainly, I think Anjali's advice about attending conferences, writing papers, networking, getting to know folks is a really good way to start to expand the number of folks who know your skills and knowledge and credentials.
And if I may add, those are all excellent. I echo everything that Dr. Wagner has said. I just like to add, produce products. So actually have tangible products. So something that, when you're going to an interview, or even if you're reaching out to somebody on LinkedIn and you show them whether it's a graphic, an infographic, or a paper that you've written, it provides them with something tangible. It gives them a way to evaluate your skills. So you should have all this knowledge and skills, but how do I evaluate whether you can do what you've indicated that you can do on your resume? So that will set you apart. And also try to amplify your signal on social media. Right now, there's so many opportunities to create that brand presence, whether it's on LinkedIn or Instagram or Twitter. So those are all other additional ways to set yourself apart.
And we do companies do look at social media profiles, so also avoid the red flags.
Mm-hmm.
Yeah, great answers. A question came in from Amy Reese earlier about, for Dr. Masa, science outreach. How would you, or I guess for all of you, how would you have incorporated that passion for outreach and education into your careers?
Yeah, I think this is a great question for this panel, especially because all 3 of us are incredibly passionate about outreach and education and engagement. I try to respond to all students. I'll get 3rd graders, and I'll get grad students and everybody in between contacting me. I don't always have an opportunity to respond to them all, but I really do try, because I think that's the most important thing. I've gotten to do some wonderful mentorship from engineering design teams that are trying to solve some of our challenges, that are coming up with really innovative technologies. High school programs like the Hunch program, helping to judge and give feedback on some of their designs. doing spaceflight technologies. We're very involved with the citizen science program, and I put the link in the chat called Growing Beyond Earth for middle schools and high schools to help us select some of the crops that are growing in space and to test out new horticultural practices. And that's also can be found through the citizen science page at science.nasa.gov. So, unfortunately, I can't do as much outreach as I would love, because if I could, I would just do that all the time. But, I try to get the message out. And I think one of the really interesting things that I've found is that one of the best ways to inspire people is by failing at something. So we've had, a lot of excitement about plants in space. We've had a lot of failures about watering plants effectively. And when I share the fact that, we're chronically flooding or drought stressing a lot of these plants because gravity makes it so hard to water your plants in space, students just get so interested and inspired to try to solve that problem. And so I think sometimes sharing failure and issuing it as a challenge can be a really motivating thing as well.
Yeah, thank you for that, Joya. Another question I found is came in from Stephen. I did not put his last name back in there. For recent graduates in between, undergrad and graduate school, what kind of opportunities are available for them, if you guys have any input on that?
Well, Axiom is actively hiring. We have quite a few opportunities. Also, not just Axiom, but other industry players. If you start to go look at the careers page on any company website, you can see that there are some more early career positions. For example, let me give you an example. For example, marketing. If you're a scientist and you really understand your art, and this speaks to what Erica had said earlier, being a translator. If you can write and be able to translate that very complex science, there is definitely a gap, an unmet need right now that needs to be filled in science writing, to be able to take that really complex experiment or those complex processes and write that and translate that into something that's more digestible, not just for the website, but for brochures and marketing collateral. Right now, we're trying to open up space, not just for the space individuals, but more broadly to non-space companies. How do we take what our language that we're so familiar with, and how do we translate that to talking to a biotech company who has never done space experiments, or to an engineering company who has never thought about space? So broaden your scope, think about it from that perspective, whatever your skills are, your knowledge base, see how you take that and can translate that into something more digestible.
Yeah, I'll add on top of that, we also have a new graduate rotation program where scientists and engineers come in, and the first year you get 3 different assignments before we land on your final one. But I think one of the things that I've found really powerful is that students and young professionals are in a unique position to use a hockey analogy, to skate to where the puck is going to be. And that if you listen to what's going on in the industry, you can see that there's these commercialization trends that Anjali's talked about. There's this press forward to the moon and onto Mars that ties into the work that Joya was presenting. There's a lot of change happening in the decadal survey that's coming out from the National Academies of Science in gravitational research. So look for those opportunities that are where things are going to be in just a couple of years. The opportunity through ASGSR right now to be part of the white papers for the decadal process is a really incredible one, not only to meet and network and hear from some of the senior scientists in our field, but also to really understand where they see the field as trending towards, and to look for opportunities that will put you in the line of that, that vector.
May I make one additional comment just to build on that a little bit further? Is we're at an inflection point. This is just a really exciting time to be a student, if you're an undergraduate or a graduate student, because space is now commercialized and not traditional space. So think about it think about entrepreneurship, think about innovation, think about invention as opportunities. If you can't break directly into a space job, in a traditional company, consider starting your own. Consider, going the VC route. Consider, pitching an idea and creating your own company. So I just wanted to throw that out.
Roger that.
In terms of companies, there are some really amazing opportunities to get into space research for small businesses, and this is an area that I think a lot of people maybe don't know about, but there are funds set aside to have small businesses and to grow small businesses. And so if you have good ideas, that could be a really interesting option for doing space research, for building hardware that will enable space research. And a lot of the space companies that are in existence now started through that program.
Yeah, thank you all for your answers. Just one last final question before we leave, coming from me. What is one piece of advice you all wish you would have known when you were starting out in your careers? You had to pick just one.
I guess for me, it's just find what makes you happy, because if it makes you happy, you'll be good at it. And if you're good at it, it doesn't really matter what field you're in. You can take it farther than you'll ever be able to take anything that you're not really happy doing. So, a lot of times people try to force themselves into a mold thinking they should be, I need to be an engineer. My dad was an engineer, whatever. My whole family tells me I have to be a doctor. Figure out what makes you happy, and your life will be so much better for it. And, figure out where that journey will take you, and don't worry about the destination so much.
I guess for me, it would be that whatever you're doing or whatever issue that you're dealing with, you're not alone. There's 100% someone else who's either having that issue or has had that issue. So the one advice would be to lean into or create a group of trusted people that you can lean into for support and advice. There have been many times when, you come up with, you hit a wall, you hit a barrier, you don't know how to move forward. Create that circle of trust, create that, that personal board of directors, whatever you want to call it, 2 or 3 people that you can go to and ask for advice, and people who have your back. That would be, I wish I had known that much earlier. Later, as I, started going down my career, that's something I realized that's something that I need to put into place.
I guess for me, the realization that took me a while was that careers are nonlinear. I think both Anjali and Joya's slides showed that really nicely visually. But if you ask someone to tell you their career story, it'll often sound like it went from A to B to C to D. But in reality, it goes from like A to Q to F to Z to R, and it only looks linear in hindsight. So embrace that. Know that that's part of the journey, and don't be scared of it. You can often learn a lot by going in a slightly different direction than right up the middle.
All right. Thank you all for your answers. And thank you all for coming and presenting. And thank you to everyone who asked questions respectfully in the chat. It was great hearing from all of you. This meeting is recorded and we will be posting it on our YouTube channel. So if you missed out on the first part or you had to step out, you can come back and watch this again. All right. Thank you, everyone. Have a good day.